let's find the indicated partial derivative. This is a triple partial derivative. This is the next step. So if we have f of xy is equal to x to the ninth, y to the ninth, minus x to the eighth, y to the eighth. What we are wanting to do in this video is basically find the f sub x, and then do it again, and then do it again. That's the first one. And then this one is f sub x, and then y x. So that's the order. So let's first focus in on f sub x. That's the first partial derivative with respect to x of f of xy, which is just going to be 9x to the 8th y to the 9th minus 8x to the 7th y to the 8th. And then what I can do is I can do f of, now here it's not useful at all actually, to find f sub y, because we're not gonna do that first for any of these. We're doing f sub x, and then we're doing x again, so we can just go ahead and do f sub x. However, if you switch up this order, you should get the same answer. So if I take f sub xyx, this should be equal to f sub yxx, or f sub something else with different combination. I'll actually just test two combinations real quick. So I'll do f sub xyx, yxx, and that should be equal to f sub y, or rather, let's go a different combination, xxy. Let's test that these are equal. Anyway, let's go ahead and take this f sub xx. So this is going to be 9 times 8 times x to the 7th y to the 9th minus 8 times 7 times x to the 6th y to the 8th. Okay, so this is 72 x to the 7th y to the 9th. I need a calculator for the next computation. So this is going to be, let's see, 48, 56, I believe. Yeah, that's 56. X to the 6th, y to the 8th. Finally, one more time. 72 times 7x times y to the 9th minus 56 times 6x to the 5th y to the 8th. I definitely need a calculator. 72 times 7 is 504. So 504 x to the 6th y to the 9th minus 56 times 56 is 56 times 6 is 336 x to the 5th y to the 8th. Okay, let's go ahead and do this one. So we already know f sub x, so starting with this one, by the way. So that's that. We can just go ahead and do with respect to y. It's going to be 9 x to the 8th times 9 y to the 8th minus 8x to the 7th times 8y to the 7th. That is accurate, I believe. Yeah, that's accurate. 81 x to the 8th y to the 8th minus 64 x to the 7th y to the 7th. Last one is f x y x, so this is with respect to x, so it's going to be 81 times 8x to the 7th times y to the 8th minus 64 times 7x to the 6th y to the 7th. What is 81 times 8? 81 times 8. 648 x to the 7th, y to the 8th. 64 times 7, 448. That's fxyx. That's this. Okay. Technically we're done with the problem, but I just wanted to prove a point that these should be equal. So all of these, so I'm going to do that in this color, so fyxx. So we actually do need the first partial with respect to y. So that's just going to be 9y to the 8th times x to the 9th minus x to the 8th times 8y to the 7th. Okay. And then, actually, you know what, I'll just keep going. So I'll multiply it all at the end. Fyx, treating y as a constant, is 9y to the 8th times 9x to the 8th minus, did I do that right? No, I didn't do that right. This is supposed to be a 7 with respect to x, so it's going to be 9y to the 8th times, and this is going to be 8 times x to the 7th times 8y to the 7th. This is looking very, very similar to what we had before. Look at this and this, because it's equal. It's supposed to be equal. It's supposed to be the exact same thing, because fxy and fyx are the same thing. So this is equal to, of course, the same thing we had before. And then, of course, fyx. Is this even necessary? No, it's not, because of the fact that here we integrated with respect to x, not integrated, find the partial derivative with respect to x, and we're doing the same to the same exact expression, so it has to be equal to the same thing. So that's actually kind of a quick trick. Really, it's not really a trick, it's kind of obvious. So they're equal. Let's try this last one, fxxy. That should be a little different, but it'll give you the same thing. So it's going to be 9y to the 9th times 9 times x to the 8th minus 8 x to the 7th y to the 8th. fxx is 9 y to the 9th times 8 times x to the 7th minus 8 times 7 x to the 6th times y to the 8th. fxxy equals 9 times 9y to the 8th times 8 times x to the 7th minus 8 times 7 times x to the 6th times 8y to the 7th. And that is equal to, drum roll, 9 times 9 times 8, 648. X to the 7th, y to the 8th, minus 8 times 7 times 8, which is 448. X to the 6th, y to the 7th. Same exact stuff. That's equal. So hopefully that kind of opened your eyes as to how they're equal. It just needs to have these three variables, x, y, x, and they can be in a different sort of order, and you'll still get the same answer. That's it.